Alright, so this is 3D and E test review. So 3D, we are adding and subtracting complex numbers. So we have to think about why the parentheses are there. And first of all, the parentheses are there because we have three different complex numbers. Complex is a real part and an imaginary part put together with addition or subtraction. Those are complex numbers. It's a whole another number system. Now, once we see we have three different parts, we're looking to see how can we get rid of the parentheses. The first complex number here doesn't have a multiplication on the side, doesn't have an exponent, doesn't have a subtraction, so we really don't need the parentheses, so the parentheses are going to be gone. So we'll have 1 minus 7i. The next set of parentheses, we have a plus, and by distributing a plus in, that doesn't actually change anything, so we really don't need the parentheses there either. The last part, though, we have a negative, and you distribute a negative, that changes sign. So negative 1, I put a 1 there. Negative 1 times 7 is negative 7. Negative 1 times 8i is a negative 8i. Now the parentheses are gone. Now we're going to look for like terms. Like terms are our constants and our imaginary parts. And you see I'm circling the signs, the operation to the left always. So we have 1 minus 5 is negative 4, minus 7 is negative 11. We have a negative 7i plus 7i is 0i, minus 8i is a negative 8i. Always try to write the real number first, then the imaginary in the complex with complex. All right, moving on to number 2. Let's see, we don't need the parentheses of the first. We're going to distribute this negative in. Negative times a negative is a positive. Negative times a negative is a positive, so plus I. We don't need the next set of parentheses. And let's gather our like terms. We have I, and I. Positive 2 plus a negative 8. So 8i plus one more I is 9i, minus 3i is 6i. And then 2 plus negative 8, or 2 minus 8 is negative 6. You always write the real number first, and that 6i is positive, so it'll be plus. Number 3. Don't need the parentheses of the first complex number, plus 6i. Don't need those parentheses. And let's distribute this negative in like a negative 1. So that's negative 5 minus 8i. Negative 3 minus 5. And negative 8i plus 6i minus 8i. So negative 8. And then that's going to be negative 2i minus 8 more is negative 10i. Number 4. Don't need the first set of parentheses. The plus, it's like distributing a positive 1, does not change anything. And like terms, we have negative 8 minus 2 minus 3. And then we also have 6i plus 6i. So negative 8 minus 2 is negative 10, minus 3 is negative 13. 6i plus 6i is 12i. Number 5, now we're getting into multiplication. So we're going to multiply 2i times negative 2 is negative 4i. And negative 2 times a positive 2i is a positive 4i times I is I squared. Now, after you multiply, you always look to simplify. We can simplify the I squared as negative 1 times negative 1. So 4 times negative 1 is going to be negative 4. We're going to switch these terms around. We want the real number first, which is negative 4, and the imaginary number, negative 4i, next. Number 6. Anything squared is the base of that square times itself. This is one way to do it. I'll do it 2 ways. And we have negative 5 times negative 5 is 25. I times I is I squared. Simplify I squared is negative 1. Multiply it, since it's multiplied here, and that will be negative 25. The other way to do it is you are distributing the exponent to each individual part of that term, negative 5 squared and I squared. Negative 5 squared is 25. I squared is negative 1, so times negative 1, which is negative 25. So you can do it either way. Number 7, we have a binomial times a binomial. So here we're going to, let me change up colors. Negative 5 times negative 4 is 20. Negative 5 times negative 8i is 40i. 3i times negative 4, now we need to distribute that as 12i, negative 12i. And 3i times negative 8 is a negative 24i squared. Now let's simplify. We have some like terms. I always like to simplify the I squared if I have it. So this is going to end up being positive 24. And now let's look at what our like terms are. 20 plus 24, 40i minus 12i. So we have 20 plus 24 is 44. 40i's minus 12i is there'll be 20, positive 28i's left. Number 8. So we have a binomial squared. So let's extrapolate this out, bring it out. So it's negative 1 plus 4i. Square means the base times itself. So plus 4i. And let's distribute. Negative 1 times negative 1 is 1. Negative 1 times 4i is a negative 4i. 4i times negative 1 is a negative 4i. And 4i times 4i is 16i squared. I like to distribute or simplify my I squareds. I'm going to rewrite this as 1 minus, and you can put like terms together if you want. I just don't like to do it until the end. 16 times negative 1 is negative 16. And then we have like terms of 1 minus 16 is negative 15. And negative 4i minus 4i is a negative 8i. All right, last two problems. Number 9, we have negative 5 minus 8i. There's nothing on the outside, no exponents, so I don't have to, nothing, parentheses can go away. We have negative 1 times 4i is a negative 4i. Negative 1 times negative 2 is a positive 2. Negative 1 times 4i is a negative 4i. Like terms, I have negative 5 plus 2, negative 8i minus 4i minus another 4i. So we have negative 5 plus 2 is negative 3. Negative 8i minus 4i is negative 12i minus 4i is negative 16i. And the last problem. We have addition and we also have multiplication. Do order of operations first. So we need to multiply these two binomials together first. So negative 5 times negative 2 is a positive 10. Negative 5 times 8i is negative 40i. 4i times negative 2 is negative 8i. And 4i times 8i is 32i squared. I'm going to simplify 32i squared as minus 32. Get my like terms together. I have 10 minus 32 is negative 22. Negative 40i minus 8i is negative 48i. So that, and now I'm going to rewrite everything else here. Negative 6 plus I don't need the parentheses, so negative 6 plus I. I'm going to rewrite plus a negative 7 minus 5i. So now I need to get these all together, all these terms. So negative 6 and negative 7 and negative 22 are all going to come together as negative 13, negative 35, and 1i minus 5i is negative 4i minus 48i is negative 52i. Okay, so that's 3D. Now 3E incorporates the quadratic formula. So you have to know your A, B, and C. Remember, this equation always has to equal 0 prior to knowing your A, B, and C. So A is 1, B is positive 4, and C is negative 12. We do x equals opposite of B plus or minus the square root B squared minus 4 times a times c, all divided by 2 times a. So opposite of 4, positive 4 is negative 4 plus or minus the square root of 16. Negative 4 times 1 times negative 12 is a positive 48 divided by 2. I'm going to simplify underneath the radical, which is the discriminant. That is 64 divided by 2. Square root of 64 happens to be 8. And now we don't have a square root left, so I'm going to just break it up into the positive and negative. 4 over 2, that's negative 4 plus 8 is 4, divided by 2 is 2. Negative 4 minus 8 is negative 12, divided by 2 is negative 6. 25. You have 1, A is 1, B, excuse me. A is 1, B is negative 4, and C is 4. The reason why I know this is because the equation equals 0. Otherwise, you cannot determine A, B, and C until the equation equals 0. So x equals the opposite of b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. Opposite of negative 4 is positive 4. Negative 4 squared is 16 minus 16 divided by 2. And we get 4 plus or minus the square root of 0. Haven't encountered that in a while, or ever. Square root of 0 is 0. Now, if you break this into two problems, you have 4 plus 0 divided by 2, which is 2. And then we have 4 minus 0 divided by 2, which ends up being 2. So you really only get one solution here. The x, or in this case, it's n, not x. N is going to, because we have n's in here instead of x's, n is just going to equal 2. All right. I'm actually going to skip 26. I'll do 27. So I need to get all the terms to one side. We do not have any like terms. Plus 7 equals 0. Your A is going to equal 5. Your B is going to equal negative 5. And your C equals 7. So you have x equals the opposite of negative 5 plus or minus the square root negative 5 squared minus 4 times a times c all over 2 times a. Opposite of negative 5 is positive 5. Negative 5 squared is 25. Negative 4 times 5 is negative 20 times 7 is negative 140 divided by 10. We have a negative 115 over 10. At this point, I need to simplify square root of negative 115. So I'm going to do that off to the side. Square root of negative 115. So the negative will come out, the negative 1 will come out as I, and then 115. Is that divisible by 4? No. 9? I don't think so. Give me 115 divided by 9, so all the perfect squares, no. 115 divided by 16, 25, no. 36, no. 49, no. Nothing's going to work. So the only thing it can simplify to is I square root of 115. So my final answer is 5 plus or minus I square root of 115 divided by 10. You cannot simplify this because you have a 5, an I, and a 10. Nothing there can be simplified in all three terms. All right, I'm going to work out number 28. So 28 is minus 2n to get what the a, b, and c are. So 4n squared minus 2n plus 10 equals 0. There is a greatest common factor here, and that's the GCF and that's 2. Divide each term by 2. What this is going to do is going to make the a, b, and c smaller. You can actually solve without doing greatest common factor, but the greatest common factor is important to pull out usually. So the a is 2, your b is -1, and your c is 5. The 2 on the outside of the greatest common factor does not have a variable with it, so that is not going to be incorporated with, there is no exponent there that like n squared. That tells us there are 2 solutions and they all are in this trinomial. The 2 on the outside does not have a variable with it, so there's no solutions there. We're not going to be able to solve for anything. So we're going to have our a, b, and c inside the parentheses there, so it's going to be x equals opposite of -1 plus or minus -1 squared minus 4 times a times c, all divided by 2 times a. X equals opposite of -1 is +1 plus or minus 1 minus 40 divided by 4. X equals 1 plus or minus square root of -39 over 4. And I would look to simplify the square root of -39. And you cannot divide it by 4. 39 doesn't divide by 9. 16, 25 doesn't work. So this is, in the end, it's just going to be I squared root of 39. And we'll do one more problem. I'll do 29. So add 10x, 8x squared minus 8x minus 18 equals 0. Greatest common factor is 2. Now there's no x with this, so the greatest common factor isn't going to be helping us with determining solutions. It just makes our a, b, and c smaller, so when we put them into the quadratic formula, they are easier to work with. So our a is 4, our b is -4, and our c is -9. X equals the opposite of -4 plus or minus the square root of -4 squared minus 4 times a times c, all divided by 2 times a. So what I'm going to do, simplify each term. So opposite of -4 is +4. -4 squared is +16. 4 times 9 is 144. Divided by 2 times 4 is 8. 16 plus 144 is 160 divided by 8. Square root of 160, let's simplify that. That does divide by 4, yes. Does it divide by 6 or 9? 160 divided by 9, no. So 9 does not work. 16, yes, that works. So 4 is going to be out. 16 is bigger. 25, no. 36, no. 49, no. 64, no. 81, no. That's halfway. 160 is not a perfect square itself, so I'm going to divide that up into square root of 16 times 10. Square root of 16 is 4, and square root of 10. So I'm going to replace, so I have x equals 4 plus or minus 4 square root of 10 divided by 8. And here I'm going to simplify 4, 4, and 8. I can divide all terms by 4 to simplify this fraction. There are 3 terms. You gotta simplify all 3 terms, their coefficients, or the term itself. 1 times the square root of 10 is the square root of 10, so I don't leave the 1 there, and then divide by 2. And there are 2 solutions. There's 4 plus square root of 10 divided by 2, and 4 minus square root of 10 divided by 2. All right, so that is the